Okay, good afternoon, ladies and gentlemen. I'm Neil Mitra. Welcome to this session of Easy Rider at MGM at Reinvent 2018. There are many other sessions going on at this time, probably, and you chose us, so we really appreciate that. So now we are here. I assume that you are connected to the automotive industry in some way. Either you were a manufacturer, a supplier, a partner, OEM, or you might have your own custom automotive use cases. So this session is perfect for you, as you will learn how, using connected and cloud technologies like Internet of Things, machine learning, serverless computing, you can build your own mobility solutions that will help transform your automotive products or services. I really love this quote that says, "It does not matter where you are nowhere compared to where you can go." So startups and enterprises like Avis, they have already started building solutions that will help the journey for their customers safer and easier in the future. Sorry, guys. So how many of you here use Avis or Budget or Zipcar for your travel? Okay, awesome. So hold your breath. There's a lot coming. You will know how they're working on their next generation platforms to make your ride safer and easier. I'm a solutions architect with Amazon Web Services. I help customers with cloud adoption and that it can be as involved and fun as chasing my little one. So what's in the menu today? We want to tell you what we had been cooking for the automotive industry. Specifically, you will learn about a solution referred to as connected vehicle solution. You will learn how to use that in a greenfield or a brownfield environment. And then you will hear from our guests from Avis and Slalom on their use cases, their vision, their challenges, and their future initiative, how they're transforming their business outcomes. So let's get started. At Amazon, we are continuously listening to you, our customers. And based on your feedback, we have been evolving our ecosystem of connected services. That includes online shopping through Amazon.com, where I hope you guys have spent a lot of time last week and early this week. At least I did. Our connected services related to the music and streaming and videos and podcasts, audiobooks. Personal assistants like Alexa. And from all these experiences that we gathered through all these connected services, leveraging our technical capabilities in the field of Internet of Things and machine learning, what we did, we built a solution referred to as AWS Connected Vehicle Solution. And we also partnered with various veterans from the automotive industry while we were doing that. So how this solution can help you? This can help you connect your vehicles. It can be cars, it could be trucks, it could be trains or bikes, whatever your use case be, to connect to a solution to quickly collect the data, analyze the data, so that you can improve the efficiency of your vehicles, or you can build mobility solutions to transform the experience. So let's take a quick peek into the solution. It's similar to a 3-tier architecture. Hello? Still okay?
It's magic.
Sorry for this, guys. Okay. So connected vehicle solution is a 3-tier architecture. First, you have the vehicle layer. This is where the data gets generated and published from your vehicles, your cars and trucks and whatever your vehicle is. The second layer is a business layer. This is where you ingest the data, you process the data, you store the data, and then you have the API layer. In the API layer, you serve all this data. And if you are an OEM or a supplier or partner, APIs are the key, because this is where you build your monetization strategies. The solution is built in a completely cloud-native way, so you can scale globally in minutes, as it uses a serverless stack. You can pay as you go, and guess what? It's open source. Nothing like it, right? So if you are a startup or it's a completely new initiative for you. That means you have a clean environment. You don't have to worry about your legacy environments, no technical debts. That means you have a greenfield environment. So how do you get started in a greenfield environment? It's super easy. You go to the AWS Solutions webpage. There is a CloudFormation template. You deploy the solution in your account, and you are good to go. Out of the box, you get different use cases like OBD telemetrics, vehicle trip information, driver safety score, and many others. And once you deploy the solution to AWS, the next obvious question is, okay, that's good. I have something on the cloud, but how do I connect my vehicles to that solution? So there are different ways to provision your vehicles, but the most common scenario is if your vehicles are coming out from a manufacturing facility, they can have embedded certificates that can be signed by your own certificate authority. And then the first time they connect to the internet, they will connect to the AWS IoT endpoint. And they will complete a just-in-time registration workflow. And if it's a success, voila, you were good. And from there, the vehicles start publishing the data to the cloud for the different use cases that you can see on the screen using JSON payload. So it's just like a phone, right? You buy a new phone, and then first time you start it, you activate the phone, it gets activation code, it gets connected to your iCloud, or if you're using Android, G-Cloud, and then it's good to go. So it's kind of same thing. So now let's dive deep into this solution. So you have your vehicles now, all your cars and trucks and bikes. They're sending the data to the AWS IoT endpoint. And what did we build for you under the hood? By the way, anyone have used or familiar with the solution? Okay, some of you. Good. So what happens, this data hits the AWS IoT core, which is our managed service for processing billions of transactions from millions of devices. We launched this service in 2015. And IoT core also brings with it a rules engine. So you can write your own routing rules to send the data to the backend services. So what happens is when the data comes, IoT core uses the rules engine to send the data to S3 so that you can keep it if you need to reprocess the message or archive the message, whatever your needs may be. And then the workflow for the different use cases are a little different. For example, if you are doing an anomaly detection and alerting, the data flows from the IoT core through the Kinesis stream, which is our managed real-time streaming service. From there, if there are anomalies, then a Kinesis application, which is a streaming application based on ANSI SQL, can find the anomalies in the data using different algorithms, like random cut forest. And then they can publish the data to a destination stream, which can invoke a Lambda function to persist the data into the DynamoDB store. And there are different tables for different types of data that you are getting. For a different use case, like trip aggregation processing, IoT core publishes the data to a different MQTT topic, and Lambda gets invoked. It stores the data into the trip aggregation table. For the other use cases like driver safety score, DTC detection and alerting, location-based services, the workflow looks quite similar. The only difference is they're getting different kind of JSON payloads. They're listening to different MQTT topics. Once the Lambda function gets the data, the code is different, and then it's persisted to a different table in DynamoDB. By the way, we are going to publish all the slides in SlideShare. So if you are taking pictures, you don't have to. You will get it in a day or two. And DynamoDB also acts as a reference data store. So for example, your diagnostic trouble codes is in a reference data table in DynamoDB, and there are many other reference tables as well. So now you have ingested your data from your connected vehicles to the AWS solution. You have processed the data using the built-in capabilities within the solution. You probably want to consume the data. And a very common use case is the visualization use case. So what we did, we also built an API hosted on API Gateway that essentially uses a Lambda function that can help you viewing all this data through your web UI or through your mobile applications. So it's that easy. But the real fun starts here. So customers tell us that, Greenfield is straightforward. We have an account, we deploy the solution, everything works, happy life. But what about brownfield environments? If we're an enterprise, we have probably a lot of on-prem data centers, on-prem applications. How we can use this kind of solutions in brownfield environments? So let's see. Let's start with the data ingestion again. So there are two different scenarios with data ingestion. Let's talk about the edge scenario first. So on the edge, you might have vehicle-to-vehicle communication. So two vehicles are going to collide with each other, they talk to each other, they avoid the collision. That can be one type of use case. Another could be vehicle to infrastructure or infrastructure to vehicle. That means your vehicle starts communicating with the solution deployed on the cloud. They can connect directly over a cellular connectivity, LTE or 5G, or many customers uses roadside units. So they're deployed on the side of the roads, and they communicate using the roadside units to the cloud. And once the data reaches the cloud, it can reach over standard protocols like MQTT or HTTP. But many customers, again, comes back to us and saying, we do not have the standard protocols. We communicate over custom protocols based on TCP or UDP. What you can do for us? So that's where you can use a solution like Greengrass if you have to do the protocol conversion at the edge. So Greengrass can help you convert from UDP probably to MQTT. We give you different kind of binaries and libraries that you can use, and then you can publish the data back to IoT core, and from the IoT core, the data is again routed to all the backend sources that you just saw for different use cases. Another option could be you do not have much control on the edge devices. So you have to do it on your own. You are getting the data as binary. So you can use a broker layer. You can have your own custom code that is running on EC2 or ECS as a container, which is continuously getting the data. It is deserializing the data. It is doing the protocol conversion and then pushing it back to the IoT core topics, from where, again, you have the routing rules, and it goes back to all the different data ingestion services that you have seen before. Another scenario could be the partners. Now, you might not have any controls on the vehicles. All you do is you get the data from different partners. So how do you do that? They can still use the REST endpoints, and they can publish the data using MQTT, HTTP, WebSockets. Or if they have custom protocols, they can send the data over TCP or UDP layer 4, and then you use your broker layer to do the conversion and send it back to the IoT core. Make sense? So now you have ingested the data. Let's see how you process the data and analyze the data. So you have seen this before. We support all these different use cases out of the box, and you might have a different use case. So what you do, if you're cloud native, you can build a similar workflow, write your own code, put different MQTT topics, put different DynamoDB tables, and you're good to go. But you might have to probably integrate all this data with your on-prem data as well. You need to enrich all this data information. So what do? You might have a relational database. You might be a SQL Server or an Oracle shop. You might have a NoSQL solution, Mongo or Cassandra or Couch. Or you might have your own homegrown time series database as well. So you can use a database migration service like AWS DMS, which is a managed service for migrating your data, replicating your data for various supported sources and targets. Or you can use the product-specific replication tool as well. Like you can just do a CDC to push your data from on-prem to the respective data services on the cloud. Also, you might have critical applications that you cannot just move to the cloud overnight, right? You might have your ERP systems, accounting systems. So what they can do, whether they're on a distributed stack or if they're in a mainframe application, they can still communicate over REST APIs or SOAP, or they can even use Amazon MQ. So now you have ingested your data, you have processed, stored, analyzed how you consume the data. You have seen this before. This API is hosted with the solution that you can just leverage out of the box, but there might be different other use cases. So you have all the raw data now in Amazon S3, and you have all the processed data now in Amazon DynamoDB. So you have all this data in your data lake. My friend Brian over there, he often tells me that data is like the new sausage. So it has different flavors, and you can serve it with so many different purposes. So now you might have serving needs for your data scientists. So they might need to do a direct query using Amazon Athena, which is based on Hive and Presto. Your data scientists might need to do machine learning. They can take advantage of SageMaker or many other machine learning services that we launched earlier today. You might have data analysts, and they're probably looking to have a search capability. They can leverage Elasticsearch. If they have a BI requirement, they can take advantage of QuickSight or partner solutions like Looker or Tableau or DeckGL. If there are business users, they might be looking for reports in different formats. So you can use a managed ETL solution like Glue, which is based on Python and Spark. Or you might have engagement platforms where you need to run your data warehousing solution. So you need to bring all your star schemas, Snowflake schemas, or any other use cases where you need to run full-scale relational databases. Hosted on Amazon RDS, you can run SQL Server, Oracle, Postgres, MariaDB, whatever you would like. Or you can use serverless Aurora options. So in summary, what you learned is connected vehicle solution helps you to quickly get started with your connected vehicles, use the solution on the cloud. It's pay-as-you-go. It's serverless. It's open source. You can leverage this solution for both greenfield environments and brownfield environments. You can customize the solution for your use cases, or you can integrate this solution with on-prem data sources or other data services that is not supported by the solution. If you want to learn more about this solution, I recommend you attend the Connected Vehicle Workshop that is happening tomorrow at 12:15. It's a hands-on workshop, and you will probably see my similar face again. And now, we want to show you how the rubber meets the road, right? And to do that, I want to invite on stage Chris Cerruto from Avis Budget Group. Let's give him a huge round of applause.
Thank you.
Thank you, Chris.
So Neil has been an incredible partner with us at Avis Budget Group, helping us to understand the connected vehicle solutions framework and actually figure out how to apply it to what we're trying to do with our strategy. I have a couple goals today. I would like to help you guys understand a little bit about what we're trying to do at Avis Budget Group in the mobility space. And I really want to highlight how we've leveraged this connected vehicle solutions framework in AWS to help advance our strategy, where before it, we were really in a very different place. Let me start with a quick intro. I lead up the global architecture and analytics teams at Avis Budget Group, and some interesting facts about me. I have a passion for music. I love to write and record and perform music. And I have a golden retriever named Jackson. So note to the audience, if you ever have to go on a stage, always put a picture of a golden retriever up there. It's kind of an automatically a good start to the session. So I know earlier Neil asked, how many people in the audience are familiar with Avis or rented an Avis budget car. If you don't mind, I'd like you to raise your hands again. If you've ever rented a car or truck from Avis or Budget, keep them up. If you've ever taken a zip car for a car share, put them up. This is great. If our marketing people could see all the people with their hands down, they would be like, these are our target audience. But what's interesting about us is this, right? We are not just a rental car company. We are a mobility company. And that term is probably a little overloaded, right? But what it means for us is that in a future world, we want to be able to provide mobility services to any customer in this globe when they want to get from point A to point B. That's the vision. So some interesting things about our company you may not know. We are a global company. We are in about 180 so countries, which is covering most of the globe. We have a global fleet that we manage that is over 650,000 cars. It's probably one of the largest fleets on the entire earth, which takes a lot of care, feeding, and maintenance. We're about a $9 billion company in revenue. We've got about 30,000 employees worldwide, and we've been in business for just over 70 years. You can see some of our global brands up there. So what I want to do is pause for a second and ask you to go on a journey with me as we talk through how at Avis Budget Group we've leveraged the Amazon solutions and changed the game. And I'm going to introduce a little video that you guys can watch, which hopefully will whet your appetite.
Avis Budget Group is paving the way for leading the industry. with a goal of a fully connected fleet by 2020. Connected cars benefit customers, businesses, and the communities where they operate. With complete self-service from pickup to return, travelers save time by using their smart device. Travelers can select a car, flash the lights to locate it, confirm space number, unlock the doors with keyless entry, and in the future, even start the vehicle. Connected cars will someday have the potential to remember personalized profiles, including preferred seat position, car temperature, and favorite radio station. Drivers can save time and arrive relaxed. Connected fleets also offer efficient one-touch returns and instant email receipts. Connected cars monitor gasoline levels and automatically calculate customer reimbursements if the car is returned with extra fuel. When shuttles are connected, customers know when the next bus will arrive, streamlining the rental experience. Connectivity benefits businesses that own, operate, or manage fleets by monitoring maintenance, readiness, and reducing service needs. Connected cars can report tire pressure, engine oil life, sensor data, and other maintenance concerns on the fleet manager's dashboard, expediting and improving car inspections. Self-monitoring cars will also send automatic service alerts. A fully connected fleet will save millions of dollars in vehicle recovery savings and other efficiencies. Working in partnership with cities and communities, data from connected cars can report road conditions, provide data insights like traffic congestion and parking usage, and navigate drivers to stores, restaurants, events, and attractions.
How about that, right? We've been in business 70 years. As you can imagine, this truly does kind of change the game for us. And we wouldn't be here without working with great partners like Slalom, with Amazon to help us take our vision around mobility and bring it to life. So we envision a world of mobility where everything's connected and everything's integrated and it's on demand. You know, our customers have higher expectations than ever. And you can imagine if they want to go from A to B, they don't even want to wait 30 seconds to get there. So our approach is really, we're taking kind of three steps to it. I'm going to talk you through it, and then I'm going to get a little deeper into how we've kind of realized this from a new platform perspective. So to reinvent rental for us means to focus on customer journey, and it's to empower those customers, right? So in a traditional rental experience, people are waiting in line at a counter, and they've got to wait, and they've got to go find their car, right? And in a world where these cars are connected, they have self-service at their fingertips. They can unlock a car, find the car, get in the car themselves. We want to digitize our business, and you saw in the video a little bit, it talked a little bit about what a connected fleet does to change how we operate. So you can imagine with these cars telling us where they are, what the fuel is, what the mileage is, the tire pressure, sensors, diagnostic trouble codes. It gives us all this information at our fingertips that let us manage those cars, utilize the cars better, do predictive maintenance, things like that. And it opens the door for us to develop brand new models that we've never heard of. And for a company like us that has been focused on rental for so long, it lets us create partnerships with other people, hopefully some people in this room, in the mobility space where, you know, we have a very large fleet. We've got some really smart data scientists and analytics teams, and we're thrilled and looking to continue to partner with people to open up the doors to make some of that vision become a reality where cities and cars and everything is all connected and talking. So now we have a connected fleet. As you saw in the video, we've set a goal to connect our entire fleet by 2020. It's a pretty audacious goal, but here's the thing. A connected fleet truly does change what we do. So to reinvent rental, what does this do for the customer? Well, simple things, keyless entry. Well, we've had it for Zipcar. So when our entire fleet is connected, anybody can push a button and open the door. It changes the game for our customers. And then imagine a customer getting to a car, getting in that car, and now they have all these things at their fingertips through a mobile app. They can turn Wi-Fi on in the car if they're traveling. They can have opportunity to activate new features. They'll be safer. They'll know that we know if there's a problem with that car, we'll be able to dispatch roadside assistance before they even have a problem. And then to digitize our business, this is a huge area for us, right? This lets us gather information from that car to predict maintenance, to measure fuel, to look at diagnostics. There's such a wealth of data here that these cars are now collecting. Some of these cars are collecting sensor data from every part of the vehicle, and it's continuing to grow and expand as we work with more partners. For us, this lets us to react faster, predict, and manage the fleet, which will help us do things like not only drive up utilization, which is good for business, but it'll also control the cost of the cars. You know, we buy and sell hundreds of thousands of cars a year. It's not an easy feat. We've got to maintain these cars, wash them, service them, make sure that they're in really good standing, and make sure that these customers have a good experience when in that car. So for us, having the car talk to us lets us do a whole lot more. And then new models, as I talked about. For us, this is about managing fleets, maybe other people's fleets. We currently do that as a business as well. Create new partnerships with other outside providers, like smart cities. How great would it be to know where there's parking available, to know if there's a roadside condition problem? And this data is so valuable, not only to us, but to others. So it's really it creates a mobility ecosystem that we are happy to be in the forefront of and trying to lead. So how do we get there, right? Well, we quickly realized that we needed to build basically a brand new mobility platform. So I'm happy to stand here and introduce to you what we call within Avis Budget Group our next generation mobility platform built in AWS. And I'm going to talk a little bit about functionally what we needed this platform to do, and then talk a little bit about how we were able to do that using the AWS technology. And then when I'm done, I'm going to hand it off to Sakin from Slalom. He'll get a little deeper into how we actually brought this thing to life. So as you guys probably know, when you're building a platform, it all starts with data. And the data architecture was absolutely critical to how we get this right. And for us, we've got data coming from telematics systems in these cars, right? And every car is a little different. But we also wanted to build a platform that could take data from external sources. If a city is going to tell us where there's parking, we need to be able to react to that, and we can't wait 5 minutes. We've got a lot of internal data stores as well that manage our fleet, reservations, and rental, and we've got other third parties that we want to acquire data from. We needed to take all of this different data in disparate formats, coming in at different intervals, in very different protocols, and be able to ingest it all into one platform. Once we get it in there, like a lot of companies, we're like, let's dump it all into a lake. Let's put it all in one centralized place where we can have access to this data across the enterprise. And then let's build operational data stores off of it so that we can actually do things with the data, update data, and build some services that wrap around it. And when we need to, sometimes we need to move really quickly. So we knew we needed some caching. Now, that little one at the bottom, you probably missed that. But down at the bottom, this little box that says consent privacy. Maybe some of you work in this space. But as you guys can imagine, we take this very seriously. It's very important for us as we're collecting data from a car and a consumer's in that car, that we are respecting the privacy of those individuals and also able to understand what we can and cannot use, right? So we knew this had to be a part of the platform built right in. And with different regulations and with around GDPR in Europe, as well as some of the laws and regulations in California, this needed to be a priority for us in the platform. So we got all this data, right? We've got it all on the lake. We've got it operational. We can get to it pretty quickly. Now we want to potentially be able to publish this data. Imagine a weather company that knew when a car's wipers were turning on or off. Wouldn't that be maybe some valuable data that they may actually be interested in purchasing? Well, we've got a fleet of 650,000 cars, so this is no small sample size for us, right? So we got all the data. Now we want to be able to publish events. And this becomes critical as the cars are reacting and telling us things. The easy example there is as a DTC, a diagnostic trouble code, right? If that car is going to tell us there's a problem, we probably can't wait more than a few seconds to react to it, right? Depending upon the problem. So we knew that this platform needed the ability to take this data but then react and publish events, not only for us but potentially for other partners on the outside. We know we needed to build APIs. Everyone's been building APIs forever, but we needed a platform that was modern, where we could build these APIs quickly, scale them quickly, and put business rules and, more importantly, complex event processing. So it isn't enough to just write a piece of code that queries a database anymore, right? For us, it's about looking over time. It's about saying, well, if this happened, and this other thing happens, and this thing might happen, I want to react to it. We also realized that we're not doing this alone. So as part of this, we needed to build APIs, expose them, and build a portal so that we could get developers, right? Amazon is big on this. AWS is huge in this, right? And building a community where everybody can contribute. And we needed to build web and mobile applications and allow others to do that and integrate with us. Now, look, if we only did that, we would be in a really good place. We'd have an incredible data architecture and a whole bunch of services, and we could build a whole lot of applications. But this is where the fun begins, and this is what really appealed to us about looking at the connected vehicle solutions framework. We needed to leverage and base a lot of what we do in this platform on analytics and data science. We're clearly not alone, and you guys have been paying attention through Reinvent, you've realized that this is the theme, right? Everything will eventually be driven off of machine learning, models, and smarts. So for us, we know we needed to be able to put this into this platform. And then once we did that, We also needed to have a way to look at it, visualize it differently, and draw insights and reporting as well to change the way our business runs. We have to manage our fleet every day. We have to move and shuttle cars from one location to another based on demand. And having analytics drive those decisions dramatically changes what we can do as a company. So now comes the fun part. I get to talk about all the things that are wrong, right? And the difficulties in going from where we were to what I just described. It seems so easy. I've been an architect my whole career, and I always laughed that like the best job is being an architect because you draw something on the board and then you're done. And somebody else has to build it, although I built stuff. So it all looks great on a slide. So how do we go from where we are to make this become a reality? We have some obstacles and pain points. I want to ask another question and get some more engagement from you guys if you don't mind. This one may take a little bit of courage. How many people work for a company that somewhere in your company you have a mainframe, an AS400, or some sort of a legacy system that drives some or part of your business? And you're all cringing. Here's the good part, we can commiserate, right? So we've been in business 70 plus years. And one of the things that we knew we had to overcome is we've been anchored into these legacy systems. They run our fleet, they run our reservations, they run our rental, they run a lot. And like a lot of companies, we kind of grew up, like everybody else, working with big partners and providers in a very bare metal-based infrastructure world. That's probably another theme here at reInvent that you've heard a million times, right? We've got a data center that's managed and hosted by third-party providers, and you want to order a server, you wait 3 months, and they drive it in a truck and they plug it in, right? We also realized as we started to connect our fleet, we've been doing this for a couple years, we realized that we have our own big data problem. And what I mean by that is just getting data off a car is one thing. Getting a lot of data off of many cars is a very different type of a situation. So for us, it became a challenge on both breadth and depth. We wanted to say, well, if this car can send us thousands of sensor-related information, we might want to store that one day for analytics, even though right now we're actually only using 1 bit. And we're going to get this car's data in an interval that could be near real time, potentially. And for us, with a global fleet, from a lot of different OEMs, a lot of different manufacturers and make models. As you can imagine, data normalization becomes a nightmare, right? Fuel from one car is not necessarily easy to understand and relate to fuel from another. And getting fuel down to 1/10 of a gallon so that we can be accurate and drive some of that, the behavior that you saw, takes a lot of work in saying we've got to understand all these different data sets. And everything's moving 1,000,000 miles a minute. So the pace of change for us is something that we knew we had to try to overcome. So we've put a lot into our existing architectures. We've done a great job investing in building out service-oriented architectures and data warehouses, just like everybody else, building APIs. But one of the things that we've kind of struggled with prior to where we are now is really handling events and creating an environment where we can consume and publish events and do it near real time. And another thing that I noticed that a lot of companies do is that they stand up and say, we've got a great analytics competency. We've got 100 data scientists, and we can do all this. One of the questions I love asking them is, are you using your analytics operationally, and are you doing it in real time? And I very rarely have found companies that are trying to get that working. What I mean by that is it's easy to take a pile of data and throw it over a fence and have a bunch of smart people look at it, draw some insights, and say, you should do X. But for us, if we get that information after a day, probably not going to help us. So we needed a way in a platform so that we could take this data and the analytics and we could leverage it real time. So as a car tells us something, we have smart analytics systems and models that are going to tell us what to do and be able to actually take it into action. You're going to hear a little bit more about that when Sakin comes up to talk about how we leverage that on scale in an actual lot. We needed performance and scaling. This is another thing, right? When you've got bare metal and you've got limited structure, I think in one of our data centers, we physically ran out of space. It was pretty funny. They're like, we physically don't have any more space to put another machine in. So you talk about scale and then time to market. So we've been on this journey for Connected for a while, and this is where we started. The edge for us is a little different from other people, right? Because for us, 650,000+ cars, all different make and models in different years. One car is not built the same as another. So we needed to say, if we're going to connect every one of these cars, how the heck are we going to do that? So we've taken a pretty diverse approach, right? We've partnered with certain OEMs like GM and Ford, where they've already got some pretty sophisticated technology built into the car, and they publish APIs or make data from the car available, which has been great. And then for other cars, we ended up building and manufacturing with partners our own hardware, our own firmware, and we embed these devices in the cars so that we can control and regulate what happens within those vehicles. So we've kind of taken a multi-dimensional approach here. And that's been really helpful for us to advance our goal to connect the entire fleet. So now we get all this data. What we used to do is this. Again, prior to the AWS world, where we've been using this connected vehicles framework, we had what we called Omega, as a traditional type SOA, right? And so we had a bunch of kind of enterprise technologies. You can see some of those up there, like we were Java, we had a lot of Oracle, and we were building services to consume this, trying to use JMS to manage some of the asynchronous stuff going on. But we were in a data center, as I mentioned earlier, with those pain points. And then we have this big System Z ugly thing over there on the right, where we've got IMS and DB2 and all kinds of COBOL and assembler and all this nasty stuff, right? Which is really driving a lot of the core business. So we had all these systems kind of working together and patching it. And we realized, well, this isn't going to cut it. So what we did a couple years back was we jumped on the AWS bandwagon and said, let's put our lake in the cloud, right? That's a good place to start. And we did. We basically said, let's use S3, let's use EMR, let's get data in there, and let's start doing some of that batch analytics. And then once we did that, we realized, okay, if we have field agents in a lot, and then this whole lot is connected, how do we get those agents to have an opportunity to use the data from the cars? So what we did is we also leveraged AWS at the time. We took some of the telematics data that was coming into our on-prem environment, and we kind of punted it into AWS. And we said, let's use all the amazing tech in AWS to build a new set of services. Let's stick it in some brand new open source databases and leverage cool tech like RabbitMQ and whatever. And then we'll build a brand new mobile app. And we did this in what we call our Kansas City Mobility Lab. So like a lot of companies, we test and pilot. We chose Kansas City as a place to get started, and we started to build out brand new applications, and all of this was driven off of the cloud. So that's where we started. Where did we end up? So as I said earlier, we were on our journey, and we realized we had all these pain points. We weren't going to scale. How are we going to get all these cars connected, and how are we going to add all the real-time analytics in, all the things I highlighted? And this led us to partner very closely with both AWS and Slalom to help us start to bring this journey to life. So here's what we did. We left the edge the same. Right? And this is where I think we fall in that brownfield category, which I think is very important for people to realize that it's not all or none, right? With the beauty of what they've got in this framework is it's a reference architecture. So you start there, kind of pick your pieces and plug it in. So we had already invested in the edge. So we're like, we've got the edge covered. But now what we're going to do, instead of moving any of that data on-prem, we're going to pull all the data direct from those edge devices into AWS. And we're going to use the power of AWS like EC2 containers and allow us to scale and provide performance. We're going to continue to leverage Rabbit, and we're going to continue to leverage the tech, but we're going to add Aurora Postgres in there, which gives us kind of the ability to scale and perform on that data. And then this middle section, this is the value add brand new piece that we were so excited to add to the stack, right? So for us, how we brought our real-time analytics into life was basing it on what this solutions framework provides. And for us, it involves plugging in tools and leveraging Lambda and Kinesis and SageMaker and making it API aware and API enabled and integrated. So as all this data is flowing through and we're capturing it all in S3 and in the data stores, we've got a real-time analytics environment available that can deploy these models direct into the databases, and we can leverage that data real-time through APIs that we build in this environment. And then we're going to put some really slick visuals on top, because everybody loves a little sizzle with their steak. So we invested quite heavily in working with Tableau and using some tools like DeckGL, which is an open source tool that I think Uber provided, that does a lot of amazing geospatial things with cars, so you can see where the cars are and how the stuff's being used. But then we didn't exclude or eliminate the use of the applications or the legacy systems that we already had, because you can't shut the stuff off. I mean, we're in a work in progress and doing legacy migration. Everyone loves that, right? Moving system of record into the cloud. And while we're doing that, though, we didn't want to wait to the finish line. So what we've done is we focused on leaving the things there that matter, API enabling everything wherever possible, replicating data from those on-prem legacy systems and getting it all into the AWS environment. So that way, going forward, everything that we do in this new next generation mobility platform is done exclusively in the cloud. For everything we need, from business rules to viewing data, processing data, building analytics, leveraging analytics, and visualizing it. So it truly has been a game changer for us, and we're pretty far along in our journey. We got a few things left to get through, and I'm going to introduce Sakin in a second, but kind of a quick little commercial plug here is, as I mentioned earlier, we're not in this journey alone. The mobility space is enormous. It's a $1 trillion business for mobility. We've got a lot of partnerships and friends. We'd love to encourage you guys, if you're interested in joining our developer program. We are publishing APIs online, building a developer portal that's now published, so you can get an understanding of the types of services we have that you can integrate with us. And this is an ever-evolving and expanding ecosystem for us. So we certainly would love help. We partner with a lot of companies that you may not know, including companies like Lyft. We have a partnership with them that we announced recently to do what was called the Driver Express program, where we provide cars to drivers that are interested in driving but don't have a vehicle. So a perfect example of how we've kind of built an ecosystem that's completely API driven that lets us actually provide a managed fleet that is connected to another partner through their app where they're recruiting drivers, and we're all working together in kind of this ecosystem. So I'm going to pause there, and I'm really thrilled to bring Sakin up to the stage. We engaged Slalom as really an implementation partner along with AWS because although we've got a lot of smart people in-house that do a lot of things, this connected vehicle solutions framework for us was pretty new at the time, and it's always good to get some strong expertise as you're going to go on your journey. So I'm thrilled to have Sakin join me up here.
Thanks, Chris.
Thank you.
Appreciate it. So can everyone hear me okay? All right, so this is me. I'm Sakin Kulkarni, so I'm a practice lead in our advanced analytics practice out of our New York office. So I manage our advanced analytics business out of there and responsible for delivery and kind of managing teams and implementing really exciting solutions here. So things that I love, I love playing golf and I love being with my family and much to my wife's happiness, not in that order. So that's a little bit about me. So just a little bit about Slalom. We're a purpose-driven consulting firm. We have about 6,000 plus people in 28 markets. We focus on a few areas broadly grouped into strategy, transformation, and technology. Really strong partner of AWS and a big fan of the platform. So when we started on this journey, we really wanted to figure out, what was really the best use case that we wanted to focus on. So, the tech is very exciting and very sexy, but what are you actually trying to solve? So we got in a room and we figured out, what are the top use cases that we can work on? And we really focused on these two. The first is really figuring out, how do we continually rent out, program or repurchase cars? So has anyone here leased a car before? Okay. So when you lease a car, you understand that there's a mileage limit that you have to have. Right? So you either hit that or you don't, but you got to return it after a certain period of time. So in this case, it's very similar. So the way that Avis kind of purchases or acquires cars is one way is through this leased program. So this idea that how do you actually maximize the utilization on all these cars and essentially not leave any money on the table? And the second use case, which is part and parcel, is how do you actually load balance the mileage on your risk or purchase cars, right? So there's also this idea that Avis Budget Group purchases cars, and how do you do that? So we really wanted to focus on these two use cases because they drive the most incremental revenue and the most value for the customer. I think the most exciting part of this project was really figuring out and working very closely with the fleet operations and optimization team about, what's the best use case for them. So, given that this is a machine learning talk, I didn't want to not put up a graph. When we started this project, we did some work in the field. We actually went to Newark Airport. So who here flew out of Newark Airport for this flight? All right, when coming at a Reinvent. Okay. Who here has flown through Newark Airport? All right, so you all know it's a very big airport, one of the most highest trafficked airports in the United States and possibly the world. So we spent several days on the Avis lot itself. So one of the things we looked at was on a given day, this was a really hot day because I remember we were on the lot itself. We looked at, one side was, the odometer reading, so the mileage on the cars, and the second one was the vehicle age. So every dot there is a car. So ideally, every dot should be on that line itself, right? That's a perfectly optimized car. The vehicle odometer miles are optimized for the age itself. But what you can see here is that in that triangle, there are a lot of vehicles that are underutilized. So it's essentially people sitting on the bench and asking to be brought in the game, but they're not being brought in the game. And there's a variety of reasons for this. When you sign up for a car, it's not necessarily data-driven which car is being chosen. These are busy men and women on the lots, and they're trying to get the cars out as quickly as possible to maximize satisfaction. But really our goal is how can we move these cars and vehicles that are kind of sitting on the bottom and move them closer to the line? So, one of the things we did is we went on the Avis lot itself, actually several times, and they're very generous men and women who work there, and they took us on many tours. They were very patient with the questions that we were asking. But essentially we were looking at from the start, from checkout to check-in, what is the actual path that it goes through, and where should we be focusing on to build this mileage optimization engine? So we decided to build it on this thing called the ready line. So if you look at, actually going back here, number 3, that's the ready line of the car rental, of the Avis lot. So that's where the cars are going to be serviced, to be cleaned. That's essentially the last step before it goes back into the rental process. So we really wanted to figure out how do we line up the cars based on their optimized mileage. So, Chris brought this up before about, data science being something theoretical. We didn't want that. We wanted something that was practical, that could be implemented and deployed on the field. So a lot of what we focused on was how do we actually recommend the vehicles to be put in the lanes? How many lanes should be for each one? What should it be color? Should it be blue, green, yellow, red? Should it be yes, no? We spent a lot of time talking to people and figuring out how do we minimize disruption in the operations and day-to-day work. So essentially what's going to happen and what's happening is that based on the optimization engine we built in SageMaker, the rental agent gets a color on a device. It's called a Zebra device, and it's can handle really cold weather, really hot weather. It's able to handle the snow and the rain, and they're told which color it should be brought in based on the priority of the car. So the way that we did this, the operational part is one thing, but the machine learning part was done in an agile way. So the first thing that we did is figure out with the team, what are the actual data fields that we want to bring in, right? It's not about just plugging in a bunch of data into SageMaker and pressing play. It's about really meeting with the folks on the ground and say, what are the things you're using? What are the fields that you're using? So we looked at, for a reservation, what is the brand of car? What is the reservation status? When was the booking date? What was the check-in time? What was the checkout time? From a rental perspective, we looked at the length of the rental itself. We looked at the class of the vehicle that was being rented. We looked at the purchase date, a ton of different variables. And this is a very strong blended team, right? It wasn't just me. It wasn't just the two folks on the ground. We had a really strong team that was doing the analysis and doing the development. So once the data fields were chosen, they were brought in and transformation was done. And we'll get into the architecture a little bit later. But we use SageMaker for the machine learning itself. So if you've been to any of the machine learning sessions here at reInvent, you'll know that SageMaker is really a really powerful tool for developers to build machine learning models. You can use the first-party algorithms that are kind of part and parcel, or you can use customized algorithms as well. So we use 2 algorithms that were part of this one. The first is integer programming for optimization. So this is kind of it's elegant, but it's fairly simple. It's actually understanding and defining what's the ideal mileage for a vehicle compared to actual mileage and looking at the delta. The second one was more for the second use case, the load balancing, and we use regression for this. The next step is actually implementing this into the device itself. So that's what the team is working on now. We're implementing the colors into this device, and Avis Budget Group's development team is working on that, and then continually iterating and providing more feedback, right? It's not just about building a model once and just kind of letting it go. You have to constantly tune and monitor and make sure that it's the right fit. The second thing that's important is also, just because it's a right fit for one location doesn't mean it's the right fit for others. So if you think about Newark Airport, that's a very large airport. If you look at an airport like Raleigh-Durham, it's a little bit smaller, right? So you got to be able to modify your model for that. So let's talk a little bit about the architecture itself. So I'm going to break it down into a few sections. As Chris mentioned, Avis Budget Group does use on-premise kind of mainframe architecture for some of its data, and we wanted to sort of adhere to that and kind of work with that, right? You can't just rip everything out and put something in. You need to kind of balance the needs of the day-to-day business. So the architecture that we have does have a little bit of a balance of the on-premise work as well as the AWS services. We did use the connected vehicle framework as a foundation. That was done since the beginning. So a lot of what you see here is similar to what Neil had talked about with some of the functions. Just wanted to go through a couple of things. The one thing that's really important is we also wanted to make sure that this worked for real time. So, you can build a machine learning model and just kind of throw it over the fence, but the fact is this model needs to be refreshed every couple of minutes on the lot. There's no excuse for a rental agent to not be able to see what the priority of the car is. In fact, he or she doesn't care, and nor should they. So we really were focused on that and laser focused on that to make sure that that happens. So let's very briefly go through the on-premise part. Mostly this is operational servers and databases. So all of the data fields that we kind of talked about earlier in the slides, those are coming from data servers that are sitting on the on-premise environment. So there's an operational database, a fleet database, as well as operational client servers. And that kind of feeds into an Omega service that helps trigger the API that's within AWS itself. So the AWS portion, I'm kind of splitting up into two. There's the data processing and the machine learning part of it. So the data processing is quite interesting. So from the API gateway, the station operator scans the barcode, and that triggers the Omega service. So you talk about the Omega service previously. That sends some fields over to the private API, and the API gateway invokes Lambda. So the Lambda service and the SageMaker service are really the main parts of this one. The Lambda receives the data inputs from the API itself, logs the details into S3, and then queries the Postgres service to get the fleet and reservation data. And when we talk about machine learning, it's really a collaboration between Lambda and SageMaker. So Lambda invokes SageMaker's endpoint, sends input data to SageMaker, and then SageMaker does what it does best. So a few things that it does, we're using Python for this. SageMaker can kind of work with both. We thought Python made sense for this one. It imports the Python models. It builds out the optimization model and the regression model, and we factored in a few different twists to it, which we'll talk about based on the nature of the business. It simulates slope, it calculates average miles, and it assigns an ideal mileage based on the car. So if you actually took an export of 100 rows of this data, every row would be an MVA number with an ideal mileage attached to it. And then once the SageMaker model does its stuff, it sends it back to Lambda, and it kind of goes from there. And that's how the real-time engine works. In terms of the operational components that we considered, it was a few things. The first thing that's really important is substitution and upgrades. So who here has been to an Avis location and has been upgraded? Okay, great. So that's a big part of the business that they run, and like I said earlier, we didn't want to disrupt any major business operations. So we wanted the rental agent to still have the ability to upgrade. So we actually implemented logic into this that takes into considerations, hey, a customer may want an upgrade. Just because a Class C car is available and that's mileage optimized, we still need to have conditions to allow for that upgrade. We also needed to look at demand horizon, right? We need to factor in when are people actually coming into Newark Airport. So a lot that we learned, and if you've ever traveled for work, you know that Mondays and Thursdays at airports are incredibly busy, right? Mondays people are picking up their cars who are flying in. Thursday people are returning cars and they're flying out. So you got to factor in, the model has to be changed and dynamic based on the day of the week. A few other things that kind of go on is cars on the ready line. So what cars are already there, right? You don't want to be recommending cars that are already there, or if cars are there that you don't want to duplicate effort. So all of this went into the model itself. It can be quite easy to just develop an optimization model, but actually incorporating these features was really the big part of it. So, we'll go through a little bit of some screen shares of some of the demos that we have. So most of this work is going to be actually embedded into these devices and used by rental agents, but I wanted to kind of talk to you through some of these executive dashboards that we built. So this is deck.gl. So deck.gl is an open source framework created by Uber. So what's really exciting about this is that it's really strong for real-time data and analytics, right? So when we looked at tools and we looked at trying to figure out what was the best thing, we knew there were two requirements. The first is geospatial analytics. We needed to be strong from a mapping perspective. And then also we wanted to figure out, what is the best way to factor these into real time. So what we're looking at here is, I believe this is Dallas-Fort Worth, and this is actually the interior of the lot itself. So you're able to understand paths and understand how things move. So from a fleet management perspective, you're able to look at those dashboards that way. You can also look at geofencing and locational analysis. So where are the cars being located now? Are they being shuttled effectively? What's in inventory itself? So this is kind of where the rubber meets the road, as Neil was saying. This is where the exciting stuff happens. So what's next? So the first thing that's going to be really important is integrating customer data. So it's not only what is the right vehicle, but it's what's the right vehicle for the right customer at the right time, right? It's all about making customers happy, so we want to make sure we incorporate customer status and customer preferences into the equation. The second is conducting a pilot at Newark Airport. So when we thought about implementing this, we didn't want to just implement it everywhere. We wanted a test case and see what works and then what could be fixed. So we picked Newark Airport mainly because of the size, because of the location, and because we sort of know the operations there. So the plan is in Q1 of 2019, we're going to be implementing the pilot and seeing how that works. And then the plan is to roll out this model into every airport in North America, or every location, in North America by 2020. So that's a pretty ambitious task, pretty exciting, but with the technology, with AWS and with the partnership that we have with Avis, it's definitely possible. So thanks, guys. That's it for me, and I'll pass it along to Neil.
Thanks, Akin. We were very excited to share this story with you guys, so thanks for being here. We know it's really late in the day. And we're obsessed about our customers, you. So please do not forget to submit the survey in the app. And now we want to open this for Q&A. If you have any questions, we're here. Just you can go to that mic, or you can probably just speak from there. And sure.
Yeah, so I think the question for everyone is the data sharing that we have from our vehicles to our cloud and our cloud to partners' clouds. All the data that we collect is going into our cloud, clearly. We need it, we want to leverage it, we want to be able to operate on it. Right now, the data that we're publishing is based more on like a subscription basis. So we're very careful about what we share. And for the data that we do collect from the vehicles, at the moment, we're anonymizing that data. Right, so we know we can provide information about that car without knowing who's in the car and stuff like that, right? And so it's kind of an emerging area that we're getting into. For us, right now, we're really trying to build our data architecture and make sure we've got everything really strong and solid and clean, normalized, and available. Yeah, so that question was, is GDPR and what's the impact? Is this an issue? So clearly, I think as all of us are working with more data and moving into the cloud, we all have to be really careful about it. So we follow all the best practices on GDPR. With Amazon, you have another benefit, right? And that you've got data centers across the globe. So if there's areas where you need to capture data only in one data center, we can do that in Slough. We've got data centers in Europe. We've got data centers here in Virginia that we're working with AWS. But we kind of take a pretty safe approach to it, which I think a lot of companies do, which is we ask ourselves, do we need every bit of information we're collecting? Like, are we going to use this information? If the answer is no, we're not collecting it. So for even like customer, a lot of that data is still kind of locked up in safe house in our legacy environments. And whatever we're going to move in the cloud, maybe we don't need all the PII information. Maybe we only need a little tiny bit, because the more we move, the more we expand the GDPR scope.
Before I get to my question, a quick segue to that, if you don't mind. In your slide, when you showed these different car,
it's okay.
In your, you showed these different car companies, right? Your OEMs, but you also had a gateway there. So that put me off, because that sort of is sort of different from what you're saying. It's not a cloud to cloud. I thought you're directly getting it from the car, and that bothered me a little bit, because the OEM controls the data, isn't it? So his point about cloud to cloud becomes important. You don't have control over the data, isn't it? The data coming out of the car goes to the OEM cloud.
Correct.
But what is the gateway doing there?
Yeah, good question. So obviously for us, for the cars that we control with our devices and our firmware, we control it, right? We're grabbing the data, we can pull it in. For OEMs, like for GM, where they have the Maven program, right, they want the data too. So you have to make a decision. Are you going to subscribe and leverage the tech that's there, where they're collecting it, and then they're exposing it through API? Or are you going to put another device in that car and pull it yourself? So we do both. It's changing every day, right? It's a crazy landscape right now where it's changing. You can't have every individual car talking to you. So when you build out a connected fleet, most of those cars are going to talk to a centralized hub or gateway first, right? So that all that can be centralized and you can wrap that with a service. You don't need every car in every parking lot talking individually to me. That point-to-point is never going to work.
I see.
So most of the OEMs, that's the approach they take, is they're going to build their own gateway, their own hub. Most of them are using AWS, fancy that, right? So the good thing is that these are partners of ours. I mean, GM is a huge supplier for vehicles for us, and it's a huge partnership for us. So it's a win-win.
Sure. Yeah. Now to my actual question I had in mind, that was to you, the analytics part. So as I understand it, the use case that you shared, you're trying to minimize or at least reduce the gap between the age of a car and the expected miles for that given age, right?
Yes.
You're trying to bring those two guys, they minimize the expected value or the error of those two. Yeah.
No, that makes sense. So essentially, you're almost like you don't want to leave any ounce of the car unused, right? So you want to maximize. Each car has an actual predicted value of mileage, and you want to make sure that that number hits it.
Correct.
So it's an efficiency.
Yeah. So that's what. So the question then is, don't you also have to build in? Sometimes you choose your own car, isn't it? So how do you mess around with somebody wants a car that happens to be the 10 cars behind, but your algorithm said that to minimize, your algorithm said this car should be in the front. So how do you balance, do you build that also into your, as a constraint sort of in your
Yeah, so is the question more about whether the person on the lot moves it or the customer wants it? The customer preference. So that's going to be in the next phase when we do customer preferences.
Yeah, here's what I would add, right? Because as part of our strategy, we want to enable self-service, so we have to take this head on. What I would say is, we can persuade you to get in the car that we think is best for you. And if you don't want to, you'll get in the car you want to. But our vision is to make it the perfect choice for you, right? So we'll position the cars. We'll either make it cheaper for you. We'll give you a better experience in that car. It's on us to solve that problem. We want to make sure that our customers have the best journey possible when they're in that car. And we want to give them choice. So when we are, like Zipcar, it's completely self-service. You get in the car you want and you drive it. There's nobody there. That's the future. So it's something we are absolutely going to have to tackle. And we're doing it now pretty well. It's psychology, actually, which is kind of interesting, Yeah.
So I have a question. For your machine learning models, how do you determine whether a certain variable needs to be added to the model and which one is not relevant, like does not move the target at all?
No, that's a great question. So there, and I kind of alluded to earlier, there's two approaches to machine learning, and one of them I don't really like, and the first is just throw everything in the model and see what works, and that's a waste of compute and resources and time. The first thing is talking to the business. So we, within Slalom, we have capabilities in the automotive industry, but what we don't have is 40 years times how many people who know the industry in and out, right? So talking to them and figuring out not only what are the variables that make sense, but what are the permutations of those, what are the aggregations of those, that's the important part. So if I had any advice for you, talk to the people who are on the business itself to get that going, otherwise your model is going to be bad.
Okay, thanks everyone.
Great.
Thanks for
you
the great
guys for
questions.
attending and the questions.
Have a nice evening
Thanks, you guys.
and enjoy the rest of the reInvent.